Good morning, students. This is Joy Varghese from Uncovering Chemistry. Now, in video 13 of our unit 8, that is redox reaction, we are going to discuss about the third type of redox reaction, that is displacement reaction. Now, displacement reaction you must have studied in 9th and 10th standard. If you remember, metal displacement, what we have seen, that is a lower reactive metal is displaced by higher reactive or active metals, what we say. Okay, that reactivity series of metal you must have also seen in the chapter metals and non-metals, if you remember. Okay, so displacement reaction, what happens, an ion, what we call it as, or an atom, what we say, is being displaced by a more reactive atom or an ion. So first we will see the definition of displacement reaction. Okay, so the definition of displacement reaction is, in a displacement reaction, an ion or an atom in a compound is replaced by an ion or an atom of another element. In displacement reaction, an ion or we can also say an atom. Understood? In displacement reaction, an ion or an atom in a compound is replaced by by an ion or atom of another compound. Okay, another compound is called displacement reaction. Clear? Now, this general form, a displacement reaction, can be expressed of the form. We can write it down. It may be denoted as. It may be denoted as. It may be denoted as x plus yz. Do you see what? Now suppose in this case, if y is being replaced by x, so it will be what? Xz plus y. Okay, this is the general form. Now in this, what we say, displacement, there are two types are there. The first one, what we are going to discuss, is metal displacement. What is the word? Metal displacement reaction. Clear? Now in this metal displacement, when we say, okay, in this metal displacement, in your book, if you see, one example is given. A metal in a compound can be displaced by another metal in a uncombined state. Okay, now here if you see an example, CuSO4 plus what we call it as Zn. Understood? Will give you ZnSO4 plus Cu. So you can see here in this case, if you see here, copper is being displaced by whom? Zinc. Understood? Now what is the reason for that? Because zinc is more reactive than copper. Understood? Now in this case, if you write the oxidation number of copper is +2, what we say, sulfur will be +4, and oxygen -2, zinc 0, this also 0, this is +2, +4, just a minute, +2, what we say here, oxygen will be -2, Okay, oxygen will be -2 and this will be +4. Okay, so in this case, if you see here, the zinc, what is say, is being 0 to +2 zinc, what we say, 0 to +2 means what? Increase in oxidation number means oxidation take place in zinc. Then when we say about copper, copper if you see, it is +2 to 0. Therefore, it is decrease in oxidation number, so it is a reduction. So this is metal displacement, what is given, one example. You can also write down in your fair book what you say. Okay. Then another example is given, that also we will see. Okay. Second, total 4 examples are given. All we will write, so it will be a practice for you. Second example is about vanadium pentoxide. That is, this will take it as 1. Okay, then 2. Vanadium pentoxide, V2O5. Clear? Now, vanadium pentoxide, when treated with the calcium, it will give you what? It is given there, vanadium plus CaO. Now, this is not balanced, so we need to balance this. So 5 here, 2, vanadium pentoxide 2, and here 5. Okay, so now it is balanced. Now in this case, if you see here, vanadium +5, oxygen -2, calcium elemental state 0, this also 0, this is +2 and -2. Understood? So when you see here in this case, what happened to vanadium? The vanadium, it is +5 to 0, means decrease in oxidation number, therefore reduction. Okay. Now same thing if you see for what we call it as calcium. Calcium, it is 0 to +2, means 0 to +2 means increase in oxidation number, therefore oxidation. Okay, so this was for what we call it as vanadium pentoxide treated with the vanadium pentoxide, 5 oxygen, that's why pentoxide we call it. Okay, then the fourth example, what is given? Third example. Third is about TiCl3, titanium chloride. Right from bottom here. TiCl4 plus 2 Mg. When you did this mixture, what you will get? Ti plus 2 MgCl2. Okay, so I think it is balanced now. Okay, now in this case, titanium +4, -1, 0, 0, Mg +2 and -1. Understood? So in this case, if you see here, who is oxidized and who is reduced? So titanium, if you see here, +4 to 0, therefore reduction, decrease in oxidation number, that we already seen. Decrease in oxidation number means reduction. Then if you see for magnesium, it is 0 to +2, 0 to +2, 0 to +2 means what? Therefore increase in oxidation number means oxidation. Okay, so this was third example. One more example is given, that is chromium oxide, what is given, the fourth one. Okay, you can see here the fourth one, that is Cr2O3 plus 2Al, what you call it as, gives Al2O3 plus Cr. Here 2Cr we can write. Other thing is balance. Okay. Now in this case, chromium, if you see, +3, -2, 0. This also 0. In this case, aluminium will be +3 and here -2. Okay. So if you see for oxidation and reduction, you can see here what happened to aluminium in this case. There is a decrease from 0 to increase. So it is oxidation. Okay. Same way when you see for what we call it as chromium here. Chromium like this, if you see in this case it is from +3 to 0, therefore reduction. Understood this part? So this is all displacement reaction, but in that also a type is there that we call it as a metal displacement reaction. Understood? So in this all case, if you see, aluminium is more reactive than chromium, that's why it is being replaced. Mg is more reactive than titanium, that's why it is being replaced. Calcium is more reactive than vanadium, that's why it is replaced here. Understood? So this was all about what we call it as types of redox reaction, in which we have discussed about displacement reaction, and in displacement also subtopic is there, that is metal displacement. Okay. In the another video we will be discussing about displacement only, but in that non-metal displacement topic we are going to discuss. Okay. Thank you very much.